This question says, aqueous hydrobromic acid reacts with solid sodium hydroxide to produce aqueous sodium bromide and liquid water. What is the theoretical yield of sodium bromide formed from the reaction of 5.7 grams of hydrobromic acid and 1.6 grams of sodium hydroxide? So this is another stoichiometry problem where we need to find limiting reagent, and as always, stoichiometry problems must begin with a balanced chemical equation. So in this case, we have HBr aqueous plus NaOH solid yields NaBr aqueous plus H2O liquid. So this is the chemical reaction. Now we need to see if it's balanced. Well, if we look at Na and Br, there's one Na over here and one Br over here. And here we have water. It turns out that this water comes from this H and this OH. This is actually an acid-base reaction. So this H and this OH form water. So HOH is one water. It's got two hydrogens and an oxygen. So said another way, this is a balanced chemical equation. We don't need to add any stoichiometric coefficients. Now we need to figure out how much NaBr we can make using all of our hydrobromic acid, HBr, and all of our sodium hydroxide, NaOH. So, starting with HBr, our plan of attack is to go from grams of HBr to moles of HBr to moles of NaBr, and then finally to grams of NaBr. So this is our plan of attack. So grams to moles to grams. You may be familiar with this plan of attack. It comes up quite often. So in this case, we're starting with 5.7 grams of HBr. So starting with 5.7 grams of HBr times 1 mole of HBr on the top, the molar mass of HBr on the bottom, which is 80.91 grams of HBr, which was found by just adding H and Br from the periodic table, their masses, times, now we need to go from moles of HBr to moles of NaBr. Well, they're 1 to 1, so 1 mole of HBr on the bottom, 1 mole of NaBr on top, times, now we need to go from moles of NaBr to grams of NaBr using the molar mass, so 1 mole of NaBr on the bottom, and the mass of 1 mole of NaBr is 102.89 grams for NaBr. And when we do all that math, we get 4.1 grams of NaBr based on the correct number of significant figures. This is 2, so that's 2 as well. This is not exactly what the calculator gives you. I apologize there. I had the wrong answer. This is actually 7.2 grams of NaBr. So we multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, all the way through. If they're ones, obviously you don't need to do that. So we get 7.2 grams of NaBr. I just wrote down the wrong one. All right, now we got to do the whole same thing for NaOH. So grams of NaOH to moles of NaOH to moles of NaBr, what we're trying to figure out, to grams of NaBr. So in this case, we're starting with 1.6 grams of NaOH. So starting with 1.6 grams NaOH times 1 mole of NaOH on top, the molar mass of NaOH, which is 40.00 grams of NaOH on the bottom, times, now we need to use the balanced chemical equation, so 1 NaOH, 1 mole NaOH on the bottom, and on top, 1 mole of NaBr. And as you may have heard me say before, the last step is the same. Moles of NaBr to grams of NaBr, moles of NaBr to grams of NaBr. So said another way, you can use the same equation in dimensional analysis. So 1 mole NaBr on the bottom, and the molar mass of NaBr, 102.89 grams of NaBr on the top. When you do all that math, in this case, you get 4.1 grams of NaBr. So, if we react all 5.7 grams of HBr, we'll make 7.2 grams of NaBr. If we react all 1.6 grams of NaOH, we'll make 4.1 grams of NaBr. Since once we react all 1.6 grams of NaOH, we only make 4.1 grams, which is less than 7.2 grams. After we make 4.1 grams of NaBr, the NaOH is gone. If the NaOH is gone, we can't possibly make any more NaBr. Said another way, 4.1 grams of NaBr, the lower of the two numbers, is the theoretical yield. And although it's not specifically asked for in this question, NaOH would be considered as the limiting reactant or reagent. So, the limiting reagent is a chemical, NaOH, and the theoretical yield is a gram of product, which is the smaller of the two grams that we could form, because once we make 4.1 grams of NaBr, the NaOH is gone.